Welcome to the concepts of physics. We are discussing conceptual physics, and in previous episode we have discussed about units. And in continuation of the previous episode, this is episode 2, PE2, and today we are going to discuss about dimension. So now we have to discuss, like we already know, what are units. There are four systems of unit: CGS, FPS, MKS, and SI system of units. We have also discussed in previous class about fundamental units, fundamental physical quantity, derived units, and derived physical quantities. Now, today's topic is in the continuity of units and dimension, and we are going to discuss more about how to find the dimensional formula, how to derive the dimensional formula, and what are the multipliers, why we need to remember them. Now, so let's discuss all these things one by one, and we will go from there. Okay. So, okay, tell me one thing. Nowadays, everybody knows GB, like data download or data upload of GB. What does it means? So yeah, so sometimes people know and sometimes they don't know. So we are going to discuss the abbreviation for multipliers and what are the multipliers in fact. So let's start from here, and the thing that I'm discussing with you, it will appear on your screen. You can stop the video there, you can make a screenshot, and you can make a note of that as well. And always remember, if you want to be in touch with me and if you want to get more and more information on the physics concepts, do not forget to like my video and do not forget to subscribe to my channel. And if somebody is in need, if you think that they need conceptual physics knowledge, or in later videos there will be another science topics related to biology or chemistry, please share my video. Okay. And so let's start from here. The first thing, I think this is the time to show you the slide. So here is the slide, and now you see that the symbol, it is written on the left side, the prefix is written in the middle, and multiplier is written in the middle, right side. So tera is the prefix and multiplier is 10 to the power 12. Similarly, giga is prefix and the multiplier is 10 to the power 9. Mega, multiplier is 10 to the power 6. Kilo, multiplier is 10 to the power 3. Hecto, multiplier is 10 to the power 2. Deca, multiplier is 10 to the power 1. Deci, multiplier is 10 to the power minus 1. Centi, 10 to the power minus 2. Milli, 10 to the power minus 3. Micro, 10 to the power minus 6. Nano, 10 to the power minus 9. And pico, 10 to the power minus 12. So now the thing is, you can see the symbols, they are also written on the left side. But my question is, why do we need to remember all these abbreviations and all these prefixes and all this multiplier? This is the main concern. Why? Because in our daily life, in our day-to-day life, we have numbers that we use to measure something, and these numbers are normal numbers that we can comprehend, we can understand. Whether if you talk about biology or you talk about physics or you talk about chemistry, then we deal with the numbers, either they are very very big or they're very very small, and sometimes that much small that we cannot even comprehend by normal counting. To understand that, to comprehend that, we have the system that we have multipliers, and by multipliers we just need to say the word, and then we know about what multiplier we are talking about. Suppose if we are saying, let me give you an example. Try to answer this question. Which of the following is the smallest? Which of the following is the smallest among other units of measurement? So, of course, I'm going to give you the few units of the measurement, and you have to tell me which one is the smaller one, okay, or the smallest one. Number 1, decimeter. Number 2, nanometer. Number 3, picometer. And number 4, micrometer. Now, you have very puzzled state, because I'm not talking about which one is the smallest among these 4 numbers, 5, 9, 8, 7, and you pick up, okay, 5 is the correct answer, because you know, you deal with it every day. I'm asking you which one is the smallest, that is decimeter, nanometer, picometer, and micrometer. You don't even know. Here we go. You have heard probably the term microns. If you did not hear, then we will discuss that thing later. The microbes, the protozoa, bacteria, these are microscopic elliptic organisms. You know about the atom. Atom is microscopic, okay? Very, 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 very tiny particle that you cannot even see by the eyes. So, to understand their measurement, now, if I talk to you that the nucleus of atom, for the diameter, the diameter of the atom is so tiny that you cannot even imagine, okay? And it is of 1 Fermi. 1 Fermi means 10 to the power minus 15, okay? Now the question is, how do you understand that? How small is that? Suppose this is 1 inch, this is going to be approximately 1 centimeter, and 1 centimeter, centi, is 10 to the power minus 3. If I'm talking about 10 to the power minus 12, it is going to be somewhere there that we cannot even see that. You understand what I'm saying? And if we are talking about 10 to the power minus 15, it is going to be even much smaller. Okay, so I would like to give you one example. What does it mean 10 to the power minus 3, 10 to the power minus 15? I will put slides there. You just see. This is just for seeing, just to understand, just to comprehend, nothing else. Okay, so now you know that why do we need these multipliers to remember, and that the best way to remember this multiplier is you make a screenshot, or not. If you cannot make, you do one thing: you take a paper, write down these multipliers from the chart that I'm giving you, and put on the wall. And whenever you're walking through that wall, just look at it, and then it will stay in your head. Then you don't need to worry for that. And whenever you need conversion to, if you will know how to do that, which multiplier to put there. Okay, so I would like to ask you another question. Which of the following is largest among other units of measurement? The same question is there, but I am asking largest one, and this is picometer, centimeter, micrometer, decimeter. These questions are just to give you an idea, to have an understanding how these prefixes you can use, and how you can know by using the prefixes which one is bigger and which one is smaller, and how to give them a name. If you tell me, then I will ask one last question. Which of the following is the greatest unit of measurement? Okay, terabyte, gigabyte, picobyte, nanobyte. Now you know GB. I was just discussing a couple of moments ago. GB means gigabyte. Okay, I have 3 more byte. Okay, one is terabyte, one is picobyte, one is nanobyte. Now you tell me which one is the greatest unit. So if you don't know, that's fine. Just to let you know, in all of these 4, the terabyte is the biggest, greatest unit. It is bigger than gigabyte. Okay, now you know by that chart where is the tera, where is the giga, you can see the multipliers. Now by the multipliers you know which one is the bigger unit. So because we are talking all the time about GB download, like we have internet package that allows that much GB to download, that much GB to upload. So GB we are talking, it means short form of gigabyte. Okay, so when you learn all these kind of small things here and there, then you have better comfortable situation that whatever you are talking about, whatever you are listening about, you understand that. And this is my purpose, to make you aware. We are not discussing right now the hardcore physics. We are preparing ourselves to understand the physics. You understand? Without knowing unit, without knowing dimension, you cannot go anywhere in the physics. So first thing, these first 2 or 3 classes are small classes. It is going to focus on the required knowledge that you need to know before you jump into the real physics. Okay? Yeah. Dimensional formula. Okay? So this is going to be very interesting, because now from this topic, dimensional formula, how do we find or derive dimensional formula? Okay, so because in last topic we have discussed units. If you know the unit, okay, if you know how to measure that physical quantity, whether it is derived or fundamental, whatever, if you know how to measure them, and if you know how to express them in the equation, okay, just like velocity. In previous topic we were discussing about velocity, that velocity is equal to displacement upon time. It means displacement is being measured in length and time is being measured in time is t, that the fundamental physical quantity is L upon t, and then we were writing LT inverse, that is LT minus 1. So it means if you know the definition of velocity, you write the equation of velocity, and then you write the measurement of the units of velocity, and now after express the dimensional formula. So what are dimensions? The question is, why do we do that? So the first thing I would like to tell you about the definition of the dimension. Dimensions means the powers to which the fundamental units of mass, length, and time must be raised to represent the derived units. You got it? One more time. The powers to which the fundamental units of mass, length, and time must be raised to represent the derived units. Okay? This is called dimensions of the derived units. Now, so if you have the units, you can get the information by the power to which the fundamental units are of mass, length, and time are raised. This is the dimension, and we will discuss later on why these dimensional equations are required. Okay, so it means, for example, velocity is equal to displacement upon time is equal to L by t is equal to LT minus 1. Did I say so quickly? No? The slides are coming back, so you can see on the slides. It means the dimension of the unit. What does it mean? When I'm saying LT minus 1, what does it mean? It means the dimension of the unit of velocity are 1 in length. That is L, you remember? L, and, or you can see here. I just wrote here. You see here, L, T minus 1. So you see that L has one power that is invisible all the time. we do not write 1. And T has inverse 1, minus 1. You see here? So when LT minus 1 is there, it means, what does it mean? That dimensions, it means the dimensions of the unit of velocity are 1 in length and minus 1 in time. So, and the dimension in mass for the velocity is 0. Why? Because when you see the velocity, the equation of the velocity, it is displacement upon time. What does it mean? It does not have mass. Mass has nothing to do with the velocity. Velocity has only to do with the displacement and to do with the time. So that's why the dimension of velocity in like a power of length is raised by 1, that was invisible. The power of time is by -1, and the power of mass, that is m, is 0. So this is about the velocity, and I think this is enough for today, and we will meet each other in the next video, where I'm going to discuss about dimensional formula, and then we will go from there. And probably next video is going to be the last one for unit and dimension, so you must have to listen the next video. What does it means to have the dimensional formula? And we will derive some dimensional formula there. Then we will discuss about some exercises. I will give you some questions to work upon it. Okay, so that's it for today, and thank you very much for listening this video. I hope you enjoyed it. I hope you learned something from this, and do not forget to like and subscribe my video. And if somebody needs the conceptual knowledge of physics, please be free to share my video with everyone who needs that. Okay, thank you. God bless you.